Hello, it's Steve, and this is Brainless Raider, a puzzle adventure game made in 3 hours for Trijam 276. In this series, we're going step by step over the process of remaking the game in Bevy, the Rust game engine, in probably closer to 3 months. This is the first time we're going to record one of these from a Twitch stream, and in fact it's the first time doing a Twitch stream in many years. Maybe not that many, maybe like 3. So the stream setup is pretty half-assed right now, but it is what it is. Today we're going to be going from this to actually having these little dudes move. The way the game generally works, the adventurer will always turn right when it hits a wall, and the goblinoid will always turn left. Obviously, right now, they're not even hitting walls. And, you know, secretly, it's really if they're hit an absence of a floor, because there aren't any walls. 3-hour game jam, you know. One of the things we need to do here, before we get into the code, is we need to add a clockwise toggle to the mover component, because unless we checked for adventure and goblinoid, we'd have no way of knowing that they would turn left or right, or clockwise or counterclockwise, as it were. So let's go ahead and add that. Okay, and then the adventure is going to turn clockwise, I believe. Goblinoid's turning anti-clockwise. Save. That's all we need to do in tiled. Let's pop over to the code. Just to get a little peek in here, since it's been a while since we looked at these templates, this means that now we have a nice little Boolean value in here. Let's go over to movement, which is going to be where our mover is, and we need a Boolean for that. I'm going to call it CW, and let's go ahead and grab that from the object data, just like we're doing with these. In fact, I'm just going to snag it like this. And then we can put CW right in here. Okay, so now we have the clockwise boolean being persisted, which means now that's going to exist inside this mover here, which we're currently not using at all. We're going to. Surprise. We're also going to need to probably add a few properties on this mover so we can track its state while we're doing the move movers, but we'll get into that as we work on move movers. Or one other thing with the mover hydrator, I want to have default values supported, but that would be a lot of extra code in here, so in a little bit we're going to add some helper functions to do that for us, which will really make a whole lot of this code a little cleaner. For now, let's get things looking right before we refactor. So we're just going to go ahead and get rid of this entirely. We don't need it anymore. We do need this to be a mutable reference. We also need a reference to our map server to refer to tile placements. There we go, and that's going to put them all in a nice little pattern. That also imported, I believe, map server from the crate. We're going to grab our active map, which for now is just going to be the first map because we don't have any map transition logic. And let's go ahead and iterate over all of our transform and mover query. I don't know if I've covered this in a previous video, but remember to use iter mute if you want to use mutable references, otherwise you'll get a weird compiler error like this. Well, actually, you don't even get any compiler error until you start using something mutably, and then it gets mad at you. We're going to be moving transform by some amount, and maybe I'll insert a little video of the way the game works, the game jam game. But the little guys like to move across the screen in little chunks, and I want to keep that behavior because I think it looks cool. So what we're going to do is effectively have a current position, a next position, and a percentage tween between the two, which means we're going to need a move percent, a target, and a position on the mover itself. So let's add those. I don't think these need to be pub anymore because the goal is for all the code that cares about a mover to be in the movement. We'll see if that stays for long, but for now that works. So the target is where we're next moving, the coordinate is where we're moving from, and then the move percent is where we're going to be in between the two, which we can then tween in a fancy way to make it look a little bit better. We got all those. We need to initialize all that stuff. The object data has an X and a Y, so target is going to be where we are currently, plus where we're trying to go with the direction. So let's go start actually with the coordinate. Is going to be where we are currently. Now this is a coordinate in tile space, not pixel space. And so is the target. So all we really need to do is add the direction that we're trying to move in at the start to the target. And then move percent, of course, is going to default to 0. What's this map about? Oh, right. No more squiggles. So we have coordinate and target, so we can start using those. All right. We need to translate these target position and coordinate positions to pixel space. And then we also need to use the percentage that we are, which we're going to have to move over time, to calculate our actual position. So we're not going to worry about the percentage yet. Let's start by getting the destination and the previous position. And actually, we're going to need a function to convert a coordinate to a position, but we're going to pretend we have it right now and we'll make it later. Or do we actually have it? Vec 3. There we go. Now, do you remember this coordinate position? Because I don't, but apparently we already have a coordinate to position function in main. So that's nice. I guess we'll keep it there for now. Do the same thing with previous position. So there's our destination and our previous position. And then our actual we're going to change where our transform is. Do I have SERP? Of course I don't have SERP. We're going to design a SERP function. If you've used Unity or Godot, I'm sure you know what a lerp function generally looks like as far as the signature. You're going from to %. What does SERP mean? It's circularly translating between the two. Actually, let's start by making a lerp function to demonstrate how that generally works. There's our lerp 3, and we're actually going to make the SERP and base it off of that. And all we're going to do here is we're going to pass those into the lerp function, and then instead of using the regular % that we're using, we're going to use % times pi times 0.5 times, and then dot sign, which dot sign and pi are both, I think pi is from here. There we go. Okay. Cool. And here we're just using % times half pi and then signifying it, which just confused the sign of the number. And that's how you get a circular interpolation, even though interpolation doesn't start with an E, so I don't understand why I should look that up. Let's look that up real quick. Yep, it does in fact mean linear interpolation, even though interpolation starts with an I and not an E. But whatever. That's just how things work sometimes. People can't spell. I'm one of them. It's fine. Life goes on. So, we're circularly interpolating our translation, theoretically. Of course, we haven't seen it happen, but it's happening. Actually, let's start with a lerp and see how we feel about how that looks, and then we can move it to a SERP later. That's fun. So, let's not worry about collision yet. Let's actually put in the %, and then maybe we can demo this working. Alright, a couple things we need to do here. First, we need to define the mover speed. I'll put that up here. We're going to make a little constant section. And also the plugin section while we're at it. And after some super secret testing, I think 1.95 is a pretty good speed to use. Theoretically, this will work, but the issue is that we really want to clamp this from 0 to 1. So let's make a clamp function too. And this is a straightforward function. Really, I think it already probably exists in some library somewhere in Rust that I don't know about. But pretty straightforward function. Nothing really to talk about there. It's a clamp. It clamps. And we're going to clamp our movement % between the values of 0 and 1. Okay, let's look at what this looks like. We'll find out. Oh, it exploded! Exploded! What's wrong here? There's definitely somewhere an error that I'm not seeing. Okay, so there's a resource requested by move movers that doesn't exist. That's the issue. I believe it's probably looking for map server, and since it's in update, map server sometimes doesn't exist, and that's causing it to break. So what we need to do here is make sure we wait until after the map thingy has loaded. So we just need to run this. So we just need to run the move movers only if we're in map load state done, so that it's not requesting a resource that doesn't exist. That's the issue. Let's see what kind of wacky behavior. Oh my lord. Oh dear. I think we do need to have that floop Y. Okay, so weird things are happening, but they are happening linearly. What it seems like is, I can't even see visually that the adventurer is starting up in the corner. He's actually starting down here. But weirdly enough, the goblinoid is starting down here and moving up there. And that's very bizarre, because you'd think it would be one or the other, not both. So first off, let's just fix the adventurer and figure out what's wrong with the goblinoid later. So it's clearly moving, the direction, the position it's moving to is correct, except it's flooped. Like, we know that. So let's floop this. So we're going to make a little function, a little helper function, down in the helpers. So that's just going to get the Y that we pass in, set it to tile coordinates rather than pixel coordinates, and then return it, but from the bottom up rather than from the top down. That is the definition of floop. Look it up. It's in every dictionary. Every single one. Read a book. I clearly don't need to describe what floop is. We all know what floop is, all right? This value as the first value, and then we're also going to pass in the tile width and the height and width. I believe that's going to be just height. Let's see what flooping did for us. All right, they're moving to the right spots. They're moving to the absolutely correct spots. They're just starting in the wrong spots, which means we probably just need to floop the object X and Y as well. This is the object X and Y. Now I'm more confused than I was before. There's two X's here. Why? All right. No wonder we had some weird behavior. Hey, we're moving normal. All right, I'm happy. That's not a whole lot to go off of in terms of determining whether or not we want to use SERP or LERP. So we're gonna just keep trucking, and when we get to a point where we have a lot of movements happening, we'll look again. And actually, we can kind of just do that now, because we still don't need to do collisions. This is pretty straightforward and easy to understand. Once you get to 1, you move the coordinate to the next coordinate, and you also move the target in the same direction. And really, this is what's going to change with collision. So let's run that again and see how LERP looks with no collisions. Look at that. So they're moving in a straight line. That's fine, you know, but I think this looks better. Don't you? That looks like they have some personality. They're taking steps, you know, with their feet that totally exist, and I totally drew them. Next up, we need to, like, collide with walls, right? Or at least collide with lack of floors. Don't walk into the void. What we want to do is check what this is going to be, and then determine if that is a floor. If that is a floor, then we basically just do this, and if it's not a floor, we turn whichever direction our Boolean flag says we should. So let's define a few simple variables to make this a little easier. We're going to make a little function to convert this flag into a direction. We're going to call it rotate. So these are the 3 directions we really care about. When the adventurer hits this wall, obviously he wants to turn right. But if he were to run into this and he looked right, there would be nothing there, so he would look right again, which would be back. I'm okay with the assumption that if you've moved into a spot, there's going to be a spot behind you, which means we only really care about the position in front, the position to whichever side we care, that character cares about, and the position behind. And for that reason, we're using forward, side, and back. And the side is going to depend on whether or not we're moving clockwise. So let's make this helper function while we're at it. I want to do it quickly and easily, so we're just going to check for all of the basic cardinal directions, because that's all we're really going to be moving in anyway. Oh, we need to define the cardinal directions. I forgot we even need to do that. So let's go ahead and do that right here, and then we'll move them up into constants later. And we're basically going to do this, where depending on clockwise, we're going to return whatever direction that means we're going. And might as well just have a default case of returning 0 in case I pass something in stupid. I mean, if we're going to make this more rusty, we'd return an optional IVEC2 that returns none if we don't pass in a cardinal direction. That's all set. So now we have the tile in front of, and we have the tile to the side, and we have the tile behind. What are we going to do with those? Well, we want to grab the tile data from that coordinate. So we're going to want to define a helper probably in BRMap. Couple of things here. We're going to have to make this function, and we're probably going to put it in BRMap. This is where we are plus forward, which is where we're going. And this is just the map being passed in. And 1 will be the floor. So this is saying if the tile directly in front of us is a floor tile, then we do something. In our case, we would be doing this. Or more realistically, we're going to make a target here that we can assign like so, and then use over here. So we can assign this in multiple places. So let's define this function while we're at it. Where's BRMap? Of course, it needs to be a public function. Now we actually also have to, I think we're going to have to floop the Y, because the tile data here is based on the pre-flooped value. So let's grab an X and a Y. Now the map width we need to grab, I guess I could grab it from map data. Does map data have a map width? Yes. So I need to dereference this because it's returning a pointer to U8 rather than a U8. We're going into the data, which is the big list of numbers that you can see in the tile map. We're using Y as the row and X as the column here. And then if it can't find it, then it's probably out of bounds. Simple as that. So we also need a few more cases for this. So let's add some else ifs. And here, since we're not continuing to move forward, we need to make sure we update the direction. Now we're going, down or whatever direction the rotated version was. Same thing with going backwards, and let's just add a little safety case here for if we're trapped in an endless loop. This might not be the logic we actually stick with for the rest of the game logic, but for now, that works for us. We're never going to be in that situation anyway. Okay, so we should theoretically be colliding with walls, or rather colliding with the lack of floors. Let's see what happens. And our goblinoid is turning left, but our adventure is not turning right. So that's interesting. Copy-paste is wonderful. Don't you love copy-paste? Now that we're done eating copy-paste, let's see what we're doing here. You're going. Look at them go. Look at them moving. They're schmooving. They're schmooving all around. They're getting stuck in corners, though, which is not good. So going backwards doesn't seem to be working because, again, I'm a copy-paste monster. All right, and they're bouncing off the end of the thing, and they're going the right directions. Awesome. I don't know why the exit's up here now. So that works, bugs notwithstanding. Ooh, I think this is actually, we need to floop this here too, don't we? It's possible that I can just do this, right? And then run it, and then it fixes itself. Is that how that works? Yes, we fixed it. We're going over to movement and looking into here. Now this is not a huge function right now, but also there's some features that it's lacking that I like, because instead of just expecting dir-x to be on there, I'd like there to be a default value for it, or at least the option to support default values, which would, if we did that, that would be a lot of extra code here per individual value, and it would all be duplicate code between hydrators too. So let's make a few of these, or a few functions. We're basically going to need one for each value type that go into the properties, find the name we're looking for, and replace it with a default value that we also pass in if we need it. Hopping over to hydrate components, make a little helpers section. So we'll start with string. We're calling these get property value from object or default, and then appending the type at the end. It's a long name, but it does what it says on the tin. So, just to talk through it one more time before I go and copy paste this 6 times and forget to fix something. We're going to the object data properties. We're iterating through based on property name. We're finding one, and then we're either using that value or we're using the default value that we passed in. Now let's do the same thing for 4 other things. Alright, so we need one for ints, floats, colors, and booleans. Returning an I64. We are returning a F64. We are returning a color. We are returning a bool. And then the simple part here is just replacing this. So now we have one of these to use for each property type. So let's go back over to movement and replace these calls with that call. Get property value from yada yada yada. Object data, we're getting dir x, and our default value is going to be 0.0. Ooh, I. It's going to be an I. It's going to be an I. There we go. And these need to be pub functions. They are pub functions. I just need to import them. We can do the same thing with y, dir y, and then we can do the same thing for clockwise, except it's going to be boolean, and it's going to be clockwise, and it's going to be false. Look at that. We have reduced the amount of code in this function quite considerably. All right. Well, that's it for this video. Next time on the stream, we're going to do basic collision detection, having the entities collide with each other, having the bencher pick up treasure, as well as having the goblinoid pick up treasure, things like that. We're going to get a basic system in for all of that to rely on, which will really actually result in a bunch of console logs probably next episode, so that'll be fun. Thanks for watching. Peace.